So we have already focused on the first method. Now we are going to focus on the second method where we are going to use the parametric value for a single coordinate and then we work our way through that. So let's say we have been given a question with two Cartesian plane equations. So let me write them down. So here you can see there are two equations. So let me name the equations. Let's say this is the first equation and let's say this is the second equation. So here we have to find the value of three variables, but we only have two equations. So what this means is we will be getting an equation of line as the answer if you solve these two equations. Okay. So how can we solve it? First of all, choose which one you are going to select as the parametric value. Okay. Here we have 7x and 3x. Here we have 3y and 3y. So definitely not 3y. Why? Because we can actually substitute. I mean, when we are going to the next step, we will be having to solve as a simultaneous equation. So 3y and 3y is very perfect for us. And we have minus 2z and 5z. Actually, if since 3y and 3y are there, I think we can go for x as 0. I mean, x as the parametric value because minus 2z and 5z will give us a specific value. So let's try this. So let's say x is equals to a parametric value. That x is equals to lambda, where lambda is a parametric value. So you can say where lambda is a element of all real numbers. So here the first equation will reduce into 7 lambda plus 3y minus 2z is equals to 7. So 3y minus 2z is equal to 7 minus 7 lambda. Okay. And then second equation will reduce into 3 lambda plus 3y plus 5z, which is equals to 2. So I can write this down as 3y plus 5z is equals to 2 minus 3 lambda. Okay. So this is the first equation, reduced version, second equation, reduced version. Okay. Now what I'm going to do is I'm going to subtract first equation from the second equation. So second equation minus first equation will be equals to 3y minus 3y is equals to 0. 5z minus minus 2z is equals to 7z. Okay. 2 minus 7 is equals to minus 5. Minus 3 lambda minus minus 7 lambda is equals to 4 lambda. Okay. So 7z is equals to 4 lambda minus 5. Okay. So which means z when x is equals to lambda. Okay. When x is equals to lambda, okay, z will be equals to 4 over 7 lambda minus 5 over 7. Okay. Fine. Now let's substitute z is equals to 4 lambda minus 5 over 7 in the first equation or the second equation. I think second equation is better because yeah, first equation is better because 2z will go this side. So sub z equals to 4 lambda minus 5 over 7 in the first equation. So that will be 3y is equals to 7 minus 7 lambda. Since this is coming this side, it will be plus 2 into 4 lambda will be 8 lambda. 5 minus 5 into 2 will be minus 10 over 7. Okay. So this will be equal to 49 minus 49 lambda plus 8 lambda minus 10 over 7 into 3. Y will be equal to this side. So this is equal to 39 minus 41 lambda over 21. Okay. So what we have come up with here is the parametric equations for x, y, and z. Okay. The parametric equations for x, y, and z. So what does this mean? Well, this means that if x is equals to lambda, okay, the parametric equation of y will be equals to minus 41 lambda over 21 plus 39 over 21 and z will be equals to 4 over 7 lambda minus 5 over 7. Okay, so these are the parametric equations. Now you can, since you have the parametric equation, you can actually find the vector equation. Yeah, let's write down the vector equation. So that will be, okay, so that will be, let's substitute lambda is equal to 0 to find the point, the position vector of point on the line. So that will be equals to x is equals to 0, right? L can be given as R equals to 0, 39 over 21 and minus 5 over 7 plus uh, we will have 1 minus 41 over 21 and 4 over 7 into lambda. Okay, so this is the vector equation. Okay, so if you want to make this equation look without fractions, what you can do is multiply by the largest denominator. Okay, so in this case, the least common largest denominator is 21. So if you multiply lambda by 21, you will get a value for all these things. So let's write that down. 0, 39 over 21 minus 5 over 7 plus you multiply everything by 21, you will get 21 minus 41 and 12 lambda. Okay. So in this question, what we have to do is, first of all, we have to select a parametric variable. So I'm going to choose z in this case because x is perfectly fine. So I'm going to use z in this case. So we are going to let z equals to lambda. Okay. So let z equals to lambda. So which means the first equation will reduce into 7x plus 4y is equals to 2 plus 3 lambda. So this is the first equation. Then we will have the second equation, which is 7x plus 2y is equals to 7 minus 9 lambda, which is the second equation. So what I'm going to do is I'm going to subtract the first equation from the second equation. So second equation minus first equation will be 7x 0, 4y 2y, it will be 2y is equals to minus 5 and plus 12 lambda. Okay. So y will be equal to 12 lambda minus 5 over 2. I'm going to sub this. Before that, let's write that down. If z is equals to lambda, y is equals to 12 lambda minus 5 over 2. Sub y is equals to 12 lambda minus 5 over 2 in the first equation. Okay, first equation is better. No, second equation is better. Yeah, second equation. So second equation will be 7x equals to 7 minus 9 lambda. Actually, since we are multiplying by 2, the denominator will be, so it will be plus 12 lambda, well, minus, because 2y is coming this side, so it will be minus 12 lambda plus 5. So 7x can be given as 12 minus 21 lambda. So x will be equals to 12 minus 21 lambda over 3. So the parametric equations have been given. So x is equals to not 3, 7 here. I have to write down 7 here. So x will be equals to 12 over 7 minus 3 lambda. Y is equals to minus 5 over 2 plus 6 lambda. And z is equals to lambda. From this, we can come up with the equation. The direction vector b will be equals to 3, 6, and 1. And the position vector of a point given on the plane can be given as 12 over 7 minus 5 over 2 and 0. So the vector equation can be given as L is equals to 12 over 7 minus 5 over 2, 0 plus lambda into 3, 6, and 1. Okay. So, yeah, this is how you have to do this. You can use either method, okay, because I have told you how to find a point of interaction also. So, yeah, you can do any method to find the answer. Okay.
Thanks for watching the 38th video in our vector series. If you found this explanation of finding the intersection of two planes using parametric equations helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master vectors, and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.